Okay, this section is about bonding in metals, so you know what different metals are. So we're going to talk about metallic properties. So how can we model the valence electrons in metal atoms? They're a little different than what we've been talking about so far. I kind of think of metals as a sponge, and so let's talk about that analogy. What you can think of is the nucleus of each metal atom is in the center and it's fixed, it's not moving, and then electrons move through the whole mass of the metal like a sea. So I kind of think of it as a sponge. The sponge material is the nuclei, and the water flowing through a sponge is the electrons moving through it. So if you squeeze a sponge, you know the water squishes out. Same thing with a wire of metal. If you put electrical force on them, the electrons are going to move from one place to another. So they're moving in a direction like when you squeeze a sponge. So the electrons are mobile, they can move if you put a force on them. And the center of the atom, the nuclei, stay in one place. So this is a little different than what we've been talking about before in ionic things. So the properties of metals are they're ductile, they can be forced into a wire shape, that's ductile. And you can change the shape of a metal. You cannot do the same thing with ionic crystals, they shatter. So on metal you can hammer them or force them into a different shape and it doesn't break them. But an ionic crystal, if you apply a force to them, they'll move these negative and positive charges close together, and if they're close together then this crystal will shatter. So you can shatter crystals. Metals, because they have this other structure, you can push and shape into different things that you want without shattering it. So how are metal atoms arranged? They're arranged in a close packed structure like this, and they're a crystalline kind of structure. And they're in very orderly, compact patterns. So chromium has this kind of body-centered cubic pattern. Gold is in a face-centered cubic. Looks a little different, the shape of it, the crystal shape of it. Then body-centered. And then this is zinc, which is really different. It's got a hexagonal, close-packed structure. So all metals have a different type of crystal structure to them. And then alloys are combinations of metals and other mixtures. It has to have one metal in it, and it can have other things in there. And they're important because we make alloys to strengthen the metal, to make it stronger. So bicycle frames are made of aluminum and vanadium, some of them. Those are called titanium alloys, and they're very strong. So we add chemicals together to strengthen the property of the metal. Those are alloys. So here's some different alloys. And we use them for a lot of different things. So surgical steel is very strong and it's not reactive in the body, so we use these chemicals in there. So every alloy is a little different. So let's try a quiz. So what do you think about valence electrons of metals? What did I say they were like? What do you think? So the electrons are kind of like an ocean of water. They can move around depending on if you push them or not. So they're like water in a sponge. Let's try our next one. In most metals, the atoms are. So what do you guys think? So they're arranged in a compact, orderly pattern, like the zinc was in a hexagonal pattern. And there's a body-centered and face-centered cubic patterns. And alloys are important because we use them because they can be stronger or better properties than the individual metal all by itself. Okay, that was short and quick. I hope you got a little bit out of how metals are put together. All right, talk to you soon. Bye-bye.